be successful at that, but we'll see. So it says find the average rate of change on the interval from -3 to 4. Well, that to me sounds like this, which would give me 7. If I'm going to use 4, I have to use the bottom equation. Minus the top equation. And divide it all by 7. This to me looks like a 0. 3 squared is 9. No matter if it's positive or negative, that doesn't matter because the squared sign will make it positive. 9 minus 9 is 0. So that eliminates at least part of it. So then we go to the bottom where I have -4 plus 3, the cosine of 4 pi over 2. Interesting. So start to simplify that, and we are left with -4 plus 3 cosine of 2 pi. Make sure you keep the 7 most of the time, because if you don't, you start to forget that. So I just drag it along as I do it. All right. So cosine of 2 pi. And if you think about it, it's the same as the cosine of 0. So we put the 0 finger down, okay? So we are looking at cosine of 0 as opposed to 2 pi. And the way you think about that is like wherever you go on your quadrant. So we start at 0, pi, and then we come back here to 2 pi. Then we go to 3 pi, and so on and so forth. You're just moving around the quadrants. So the first quadrant, second quadrant, third, and then fourth. We know both of them are going to be positive. Sine and cosine are both going to be positive. When you do the adjacent side, you really need the x-axis. So that is going to start making that negative. So if we do, let's do sine and cosine. So our sine is still going to be positive, but now our cosine is going to be negative. Down in the third, they're both. And then in our fourth, the sine function becomes negative. And then the cosine comes back to positive because our adjacent side is that x-axis where the sine is the y. When you start to draw the triangle, because anytime you draw that triangle, theta has to be within that x-axis type situation. And then when I start to draw my opposite side, it becomes negative. Opposite side, positive. Opposite side, still positive. Opposite side, negative, because opposite of theta is that y value. And then, like I said, the adjacent side becomes that x-axis. So when we do this, we're doing the cosine of 2 pi or the cosine of 0. So you break everything back down into the first quadrant, because the first quadrant's broke into 0 and 90. Then we have 30, 45, and then 60. So we put down the 0 finger, and when we put down the 0 finger, oh shoot, I can't, hold on. I want to make sure that I can see myself in the screen. What? Oh my god, what is, oh my gosh. Whatever, I'm over it. What is going on? It's telling me to log in so I can see my chat. Oh, come on. Not what I need right now. I'm sorry. So when I look at my hand, we have 0, 30, 45, 60, and 90. Put down the finger. The cosine is going to be the square root of the fingers divided by 2 up top. The sine is going to be the number of fingers below. And it works for each one of them. And then depending on what quadrant you're in, when we just did all this, the sine, cosine stuff. Oops, that's a cosine. We did all this, that's what you have to worry about with the sines. So it all comes back to 30, 45, 60, 90, and then just put the proper sign on it, whether you're doing cosine or sine. So we are going to do the 0 finger, so I'm going to have the square root. Let's do -4 plus 3, and then we're going to do the square root of 4 over 2, and then put our 7 down here. Because we put the 0 finger down, cosine's above, so we have 4 fingers, so that will be a 1. So then I have -4 plus 3 over 7, which will be -1 over 7. Hopefully, if I did that correctly, we should get -1/7. So let's take a look. How did we do? -1/7. Yeah. See? Now, look at what they do. That's crazy. Like how do you, I don't know. But yeah, -1/7 will get us there. Now it says write an equation for the line tangent of f at x equals 3. Ooh, so where does 3 come into play? Is it between -3 and 0 or 0 and 4? So that already starts to kind of set up, as much as I'd love to use the top one for this, we have to use the bottom one because that's where 3 falls. And when we do the line of tangent, you need a point. So our point is x1, y1. So our x value we know is 3. So we're going to have to plug that into this to get a solution. Cosine of 3 pi over 2. So thinking about that triangle, we are down here, theta. Because if we go to 4 pi, so 4 pi would get us back to 4 pi over 2 would get us back to 2 pi. So that would get us back to 0. So when we think about this, 2 pi or 4 pi over 2, that gets us right here. So 3 pi over 2 really is a negative, and the negative just tells you direction of pi over 2. Well, pi over 2, what do we do? Well, where's pi over 2 land? What is theta? Well, if we think about it, and we think about it in terms of 0 to pi, where does pi over 2 land? Right here at the 90 degree. So where's 3 pi over 2? Down here. So really we have a triangle that is not really a triangle. But when you're doing cosine, though, it doesn't matter because we can have that situation where this is negative, or let's think about this. Cosine is the adjacent side. We don't have an adjacent side. That's just 0. This whole thing goes to 0. Oh, all right then. I can get on board with that because there's no adjacent side. We don't go right or left any, and that's the side we really need. And since it doesn't, it's 0. Now, how do we know? Well, let's put down our 90 degree finger. How many fingers are above that? None. So that's how you get the square root of 0 over 2, which is just 0. So that whole thing just becomes 0. Ooh, I screwed up though. Because what's in front? We still have what? A -3. So this still, -3 plus 0 gives us -3. Sorry. Moved a little quick. So now I've got y minus -3. I still have this dy dx, and then I have x minus 3. Now our dy dx, yes, we're going to have to take the derivative of this function. So we're going to get a -1. The derivative of cosine is negative sine, and whatever's in parentheses, keep in parentheses. But then what we're going to do is multiply it by the derivative of what's inside, and that becomes pi over 2. Just like if you had 2x, 5x, I don't care what number you put next to x, you're going to get the coefficient of it every time when you take the derivative. So if I have pi x over 2, it's really pi over 2 times x, and then the x just disappears and you're left with pi over 2. So if we wanted to really clean this up, but we don't have to, we would have 3 pi over 2 and then the sine of pi x over 2. Okay? Now, that's all well and good for the derivative, but we need the derivative at that point. So we need to plug our x value in, which gets us to 3 pi over 2. Now, we need to do the sine of 3 pi over 2 instead of the cosine. And that starts to change our game because that's not 0 anymore. That's actually 1. So now I'm going to get -1 minus 3 pi over 2. So I'm going to get y plus 3 equals -1 minus 3 pi over 2 times x minus 3. I think at this juncture, write an equation for the line and tangent to the graph. I think at this juncture we're okay. Let's take a look and see how we did. But I hope, fingers crossed, we did okay. So select a point value, earning, or examples response. First point is earned with a correct and labeled value of f prime equals 3. Did we label this f prime equals 3? Yeah, I don't know. I don't think so. I think this needs to be f prime at 3. And then if you kind of continued that, f prime at 3. But if I would have labeled it dy dx equals this, I think I could have gotten away with it. So yeah, that could be a little sketch there. The second point is earned with a consistent tangent line equation created from an incorrect value of f prime at 3. So did we... Okay, so f of 3 was -3. We did that okay. We took the derivative and we got that, and then we did this. Awesome. Right in, I bet. Man, I hope they wouldn't do that to me, but I'm sure they would. But because I didn't move this over, because I'd have to move that plus 3 to the other side, they might not like that. I don't know. It's tricky. It's tricky. As much as I hate to say that, for all the good work we did. But I would hope that if they did y, an equation though, I guess if you want to be a stickler, it says an equation, and an equation is y equals. So be a stickler. Find the average value of f on the interval -3 to 4. Find the average rate of change. Okay. Find the average value. So what that to me means, I want to integrate from -3 to 0 of f of x dx plus 0 to 4 f of x dx. Find the average value. And then we have to do 1/7 times that whole thing. Because the rate of change is the slope, so we would have to integrate it to just get the value. But before we start, let's take a look just to be on the safe side. So they want the constant 1b minus a is part of the fourth point. So 0 and then 0, add them together. Yep, okay. All right. Hey, nobody's perfect. We're just trying to make sure we have some practice with these problems, and they are tricky. They like to be complicated, so we just have to go with the flow. All right, so let's do this. So square root of 9 minus x squared, x plus 3 cosine pi over x2. All right. Okay, and we have everything else. Okay, so let's glide this back down to where it needs to be. There we go. Okay, so for this one, when we look at 9 minus x squared to the 1/2, we want to integrate that with respect to x. And I'm curious because if I do u substitution and then I take du equals negative 2x dx and then I solve it for dx, I should have a negative 2x somewhere. And I don't see it. So u substitution doesn't work, and then that kind of throws the whole game off. Wow. All right. Time to cheat. So integrate negative 3 antiderivative. Of course. Wow, how do you just put that? Oh, is that an inverse tangent? Oh my goodness, what a crazy problem. And the second half seems well enough. Oh man. So inverse trig functions, it's going to be an arc or an inverse trig function. Oh my goodness. And then I plug in negative 3, take away 0 without a calculator. Interesting. Well, let's take a look. Let's at least do this for a second. Let's get rid of that. I'm going to have to do a little research for that one. But let's talk about negative x and integrating that. We're going to raise it 1 power and then divide by that power. Okay. Then we could even integrate 3 cosine of pi x over 2. And this is just a good u substitution problem because we're going to do pi over 2x, and then we take the derivative, we're going to left with pi over 2 dx, and then we can swap it so that 2 over pi du equals dx, and then we can plug it in so that we have integrating 3 cosine of u times 2 pi du. And we can take that constant out and do 6 pi, and then we can integrate cosine of u du. And what gives you a cosine? Well, sine of u gets you a cosine. And then the u we can substitute back in is pi over 2x. Put the sine in there, 6 over pi, and then x squared over 2. And then we have to do that from 4 to 0. So we're going to plug 4 in, Then we're going to plug 0 in. So we're going to get 16 over 2 plus 6 pi sine of 4 pi over 2, which was 2 pi, which we did this a long time ago. That's 0. So so this is f of 4, and then we have to do f of 0 now. So we're going to do 0. So this whole first part is just going to go to 0 plus 6 over pi sine of 0. So then sine of 0 is just 1, so that's going to be 6 over pi. So when we do this, we're going to get this, take away that. So we're going to do negative 16 over 2 minus 6 over pi, because you have to do f of 4 minus f of 0 once you integrate it. We're going to plug in the top value, then subtract the bottom value. So the second piece is going to be looking like this. Then the first piece is where we have to, it's got to be an inverse trig function. But anyways, let's take a look, because I want to make sure I did this. That's just coming out to be negative 8. Interesting. I did 6 over pi. That was fine. Sine of 0? Oh, sine of 0, not cosine. Sine of 0. So sine of 0. But then that would change the top one, wouldn't it? Sine of 2 pi is still sine of 0. Oh, we just did it here. We said it was 0. That doesn't change. It's still 0. Kind of an idiot. If this is 2 pi, and we already did it, and we said it was 0, then because 2 pi and 0 are on the same spot, it's just 360 versus just starting at 0. Oh, man. Dang. So close. So close. So then, yeah, that just becomes negative 8. Bummer. Mistakes and wrong answers are opportunities for growth and learning. So hopefully you saw my mistake. This and this are generally the same idea. They're both 0. So this is negative 8. Now comes the fun part. So let me do this. And let's just inverse trig calculus. Let's see if we can get some. Wow. Internet is slow today. What is the deal? Come on now. Why is my internet being goofy? Oh, I bet I know why. Let's take that out. Okay. Maybe that will help. I don't know. Guess we'll find out. So 1 minus x squared oh, square rooted. So sine inverse of x equals 1 over that. So if that's the case, wouldn't it just be sine? Sine inverse of x is 1 over sine of x, and if it's equal to 1 over 3 minus x squared, 3 squared minus x squared. Yeah, I don't know. I'm gonna have to think about that for a second. Yeah, I might have to do some research for that one. And really, probably watch a video or two. Man, my bad. Just yeah, I'm gonna take a hard pass on that for right now, but I will get it. What a crap shoot of a question. All right, D. Must there be a value x where f of x attains an absolute maximum over the closed interval from -3 to 4? Justify your answer. Well, we've already done the derivative of at least the top. So what we're looking for maximums, take the derivative, find the critical points, see where it changes from increasing to decreasing to get that maximum value, and test the endpoints just in case. And there we go. So we're looking from -3 to 4. So there's 2 of our critical points. We need the derivative of this, which I think we pounded out a couple. No, we took the derivative of that. Oops. So this is our derivative for the bottom part. Can we set that equal to 0? So -1 minus 3 sine of, and that's what these open response, they tend to use a lot of the previous problems information. That's about pi over 2. Okay. Set this equal to 0 and then solve it so that we can find, so that's this, pi over 2, so then that would be 2 over -3 pi equals the sine of pi x over 2. Take the inverse over 2 inverse of 2 over 3 pi. Yuck, what? just got crazy. We call it 2 sine inverse over pi x. So this over here, 0. And then 1/2 9 minus. Yeah, that was right. 1 over 2 squared times 2x. So x over square root of 9 minus x squared. So then that's just going to be 0. Pick a number smaller, and this is going to be positive. Pick a number larger. Larger than 4, or no, that's 1. Pi over 2. Sine of pi over 2 is 1, so then that would be negative. So then our thing would be at 0. There must be a value of x at which the function obtains an absolute maximum on the closed interval. Let's define our answer. The first point will be evaluating each branch of the function at x equals 0 instead of evaluating one side of the limit, but with the second point, correct the limit notation, clear limit notation. F of 0 equals 3. In the statement, the function continuous in the closed interval. Therefore, the maximum value is specifying the extreme value theorem is not required to earn this point. Responses that indicate the function is differentiable on the point will not earn the point. So we can show the limit as x approaches 0 from the left, which is the square root of 9 minus x squared, and then the limit as x approaches 0 from the right of so when we plug 0 in, the cosine of 0 is 1, so that's going to be, so this is 0, the cosine of 0 is 1, so this is going to be equal to a 3. Plug 0 in, square root of 9, this is going to be equal to a 3. The real question is, continuity at x equals 0. Well, we plugged it in and got 3 on the left and the right. The first point is earned by evaluating each branch of the function instead of evaluating one side of limits, but the response will not be eligible for the second point. The second point is earned with the correct limit notation for the first point, clear communication. So then we'd have to do f of 0 minus 0 squared square root, which is 3. And then f of 0 is negative 0 plus 3 cosine of pi 0 over 2, which will be 3. But why do we know that 0 is the maximum value? That will be the tricky part. Huh. Interesting to say the least, but we made it through. Sort of. So, I've got some work to do with the integration of the top. All right. So, classic graph. Well, looking at f looks like a normal f, like just a graph, but when you look at this, if we integrate f of t dt, that would give us, oh, well, yeah, so they're just using the first rule, the fundamental theorem of calculus. Find g of 0, find g of 4. Or 3 and 5 respectively. Okay, so they tell us that the A section is a 3, and they tell us that the B section is a 5. The graph has horizontal tangents at negative 1/2, 1/2, 5, or 2. It is known that f of x equals this from 1 to 4. Okay, so they're just giving you different pieces. So the first one, g of 0, we want to, so for g of 0, we want to go from negative 4 to 0. So we want to take the area under the curve. So we know this is negative 3 because it's underneath the x-axis. We can turn this into a triangle and have 1, 2, 3. So the base is 3 times the height, which is 3, times 1/2. So that's 9/2. So 9/2 minus 3, which would be 9/3. Then turn 6's. Over 6 minus 18 over 6, which is 9 over 6, or 3/2. So we had to find the area of this triangle. Then we know the area of this because it said the regions A and B are bounded, and then they are 3 and 5, so I know this is 3. It's underneath the graph, so it's negative 3. And let's see how that plays out. So 3/2, yep. And then we still have to do the other one, so that's what we've got to do all this other stuff at the bottom. But that's the first part. That was g of 0. Then we can go to g of 4. So now if we do g of 4, we're looking at from negative 4 to 4. So we know this is negative 3. We know this is positive 5. We know this was 9 over 2. Correct? Yep, 9 over 2. And then we need this area under the parabola. So we need to integrate from 1 to 4 of our function they give us. Negative x squared plus 5x minus 4. And that's going to be negative 1/3 x cubed plus 5/2 x squared minus 4x. and then we're going to go from 4 to -4, plug it in, plug and chug that, and that's what they're doing here. So we did so we're going to do these 3 pieces added to this one here. So when you see 3/2 plus 5, they combine these two. So that would be what? 6/2. So 3/2 minus 6/2 is 3/2 plus 5. And then they integrate and do all that. And that's how they get that solution. Find the absolute minimum in the graph of G on the interval. Okay, so when we look at this, think about it as this is the derivative graph. So this is positive, this is negative, this is negative, this is positive, and then this is positive, positive, positive. So the only way to go from increasing to decreasing creates a maximum, but going decreasing to increasing creates a minimum. So you would have to show that I would do it this way. So actually, I'll just leave it here. We'll say the limit as x approaches 0 from the left, f of x is less than 0, and then the limit as x approaches 0 from the right of the function is greater than 0. Therefore, this creates a minimum value. And it probably should. Let's see what they have to say about it. Let's go part B. So the first point is earned by the explicit statement connecting f prime to f. Note that it is possible that this connection is made in the earlier part will earn the point here. The second point is earned by the values appearing in the equation table or paragraph. Identifies x equals -4 and x equals 0 as candidates. Slopes so negative from -2 to whatever is there, 1/2, and then 1/2 to 1, and then 2.5 to 4. So I was just looking at find all the intervals for which G is concave down. So you want to say the slopes are negative from -2 to in between 0 and 1 is 1/2, -1/2. And then also from a positive 1/2 to 1, they are negative slopes. And then from 2.5 to 4, they are negative slopes. So all those indicate concave down. -2 to -1/2, 1/2 to 1, 3, 2.5 to 4, because f of x is decreasing on these intervals. Yeah, so I'm gonna have to do some research on 4b. Not that I dislike it, I just I don't know. I want to make this connection, I guess. Okay. So we'll do that, and then I will research 3 as well and figure out how to integrate that. So I've got some homework for myself. Rest of you fill in as much as you can. Do the best job you can. This is why we're practicing it. And remember, like, once again, 0.2, half 2, full 2. That's what they're looking for. They want you to just do your best. They're trying to create problems that are ridiculous and are going to get messed up here and there by a negative or thinking we're on a different path. So take it in stride. These are not simple. I've been teaching calculus for 4 years now, still getting stumped on these, 5 years. I think, yeah, 5 years I've been teaching calc. They're just difficult. They're tricky, So, I mean, it is what it is. You just have to take it in stride, understand it's an AP test, and they're trying to make people screw up and try and get things wrong. So just take it slow, do it step by step, and see what you can come up with. All right. Keep watching. Nothing else. Have a blessed day, and we'll check with you next time.